what's anything divided by itself? 1. Now on the right side, you say you're going to get something very, very complicated. And you will. But it turns out that after all of that complication, what is represented on the right side algebraically is the same as r squared, which is an amazing fact. Because is this not the amount of explained variation in y? The difference between the mean and the point on the regression line is explained, agreed? So is not r squared the percent of the total variation? This is the total variation, true? So the percent of the total variation that is explained by correlation is r squared. And this is equal to unexplained. So you also see that the unexplained is equal to 1 minus r squared. So, yes ma'am?
Divided by y minus y bar squared.
Oh yeah, it's
So,
a
those are all-
notation problem.
okay.
I've told you about that 100 times. You do it once more, and it's going to be bad. It's not my fault, it's my hand. Okay, nailed. Okay, so you see this quantity r appears once more. That r squared is the percent of the total variation that is explained by correlation. So r is the strength of correlation. So r equals the strength of correlation. And r squared equals the amount of correlation, the amount of correlation, the amount of variance of deviation that is explained by correlation. And now you're able to actually answer some homework problems. So let me hit you with an easy one. I do hope you have these printed out somewhere. Does anyone have them printed out?
Yeah,
Do you have these, Lane, chapter 4, 14, and Ilkowski, do you have the questions printed out?
Yes.
Okay, so, so let's go to Lane, chapter 14. Lane, chapter 14. So, Paul, can you read question 16 to me?
Well, I've got all of it printed out here, but it's all kind of mixed up here. I don't know which chapter here.
So it's page 515.
Okay, that helps. Yeah, I have it all.
Page 515.
You said 14?
That's right, 16.
Oh. True or false? If the correlation is 0.8, then 40% of the variance is explained.
So I'll read it one more time, let it sink in. If the correlation, what's a symbol for correlation? R or rho, agreed? Is 0.8, then 40% of the variance is explained, true or false? Find your answer. That's right. R squared is the amount of explained correlation, isn't it?
Yeah,
So if R is 0.8, what is R squared? Mm-hmm. Nux already knows. What's 0.8 squared? 0.64, all in favor? So, if the correlation is 0.8, then what would a true statement be? 64% is explained by the correlation, true? Because R squared is the percent of explained. And if R is equal to 0.8, then R squared is equal to 0.64, not 40. So what do we get for that answer? 5. Okay, now let's look at 13. Now I need to remind you, it says, does A or B have a larger standard area of the estimate? I need to remind you that the standard area of the estimate is the average residual length. The average residual length. So does picture A or B have a larger average residual length? Paul? B. B has a larger average residual length, which is loosely speaking the standard area of the estimate, because the residuals are larger. So is the standard area of the estimate not a measure of how tight the points are about the regression line? Okay, 17. Karen, can you read 17?
If the actual y-score is 31, if the predicted score is 28, then the error of the prediction is 3.
Okay, so these are just different terms for the same old items. So this is the predicted value, or explained, right? And then the residual is called the error of prediction, agreed?
Yes.
So it's just different words for the same items. The error of prediction. True? So is this a true statement or a false statement?
True.
True statement, agreed? Sean, true? Yes, because if the actual y-score was 31, that means that this score is right here. Oh, the actual y-score, oh, maybe I got sloppy too. The actual y-score was 31. Okay, now, and the predicted score was 28. Aye, it's false, because this is not what was 31. I fell into the trap, just like everyone else, agreed? And boy, it smells bad, doesn't it, down in this gunk? If the y value was 31, I read that as if the deviation was 31.
So the predicted score is not y bar.
The predicted score is a y prime minus y bar.
Oh, right.
Oh, yeah, the predicted score is the line of regression. That's what the line of regression does, it predicts scores.
Yeah, that's what it,
Now, I'm going to tell you why the line of regression is important. Back in the original population, you have a very large number of data points, true? Now, in the original population, are you in a position to calculate rho? Or are there too many data points to calculate rho? There are too many data points. So what you do is you take a sample. You take a sample number of data points. And in the sample number of data points, you create your line of regression. And you get an R value. Now what you would like to do is to claim that the same line of regression is present in the population. You would like to claim that the same line of regression is present in the population as in your sample, because it's the population that you're interested in. So when are you permitted to claim that this line of regression is true also for the population? You have to do a hypothesis test, because this sample is one of an infinite number of samples, is it not? So will it not have a sampling distribution? And the sampling distribution is subject to a hypothesis test. So you take your sample R, and what you do is convert it to a t-value, and you plot your t-test someplace on this distribution of R's, and then you take your alpha that you're permitted to have, and you see whether your R value is going to allow you to project this back onto the population. Now, before you do that, you have to have a null hypothesis. What is the null hypothesis that you are attempting to test? The only one that you can test. You originally judged that in the original population, there is no correlation. So your null hypothesis for testing your sample R against the population is to assume that the original population has no correlation, because that's the only single number. You can only test against a single number. And that's the only single number that exists, is that the original population is uncorrelated. Now, if your t-test comes out in this zone, it causes you to reject the null hypothesis, agreed? And the null hypothesis is that rho equals 0. So if your t-test comes out in this zone, you reject the null hypothesis. And if you reject the null hypothesis, then what is it that you're accepting?
That's not zero.
That's right. You're accepting that this line can go over there. So when you do a hypothesis test for correlation, you test against a rho equals 0. And if you fall in the reject zone, that's good news, because you're rejecting a rho equals 0 in the population. You are accepting your sample results back into the population. So what you want to do is to reject the null hypothesis when you do a sample R hypothesis test. Okay, so let's go to Lane chapter 14, problem 8. So Kayla, could you read Lane 14, chapter problem 8 to us?
The correlation between years of education and salary in a sample of 20 people from a certain company is 0.4. Is this correlation statistically significant at the 5% level?
Now, what that means is, can you project this value of R back onto rho? That's what statistically significant means. Can you project it back onto rho? So let's look at what we have in this problem number 8, Lane, chapter 14, number 8. We have done a sample test. And in our sample test, we have found that R is equal to 0.4. Now, we don't know yet about the population. We don't know about the population, what rho is equal to or not in the population. So, in the population, we can only assume that rho is equal to 0, pending the results of our sample. So, in our sample, we find R is equal to 0.4. And the question is, can we project this back onto the population? So you have to do a sampling distribution. And you're going to test against rho equals 0. So you're going to have some T critical, and the T critical is given as alpha equals 0.05. True? Now you're going to find your T test. And the equation for finding T test for a correlation is one that you haven't seen before. T test is equal to R times the square root of n minus 2 over the square root of 1 minus R squared. This gives you your test T for a correlation sample. So in this problem, we have n is equal to 20 and R is equal to 0.4. So now it's calculation time. I want everyone to calculate the value of R.
Need a T?
T. Thanks. What you got, please?
1.85?
1.85.
1.5, 164.
Let's get two more. Then you get it?
Yeah, 1.845.
1.85. Okay, so now what we have to do is to take our alpha is equal to 0.05. So what is T critical? So from the T table, what's the degrees of freedom equal to?
18?
18.
But is it two-tailed or one-tailed?
It's
Oh,
always
it's two-tailed.
two-tailed because correlations can be positive or negative. You're only interested in the strength of R, not the sign. So you go to your T table and you look up alpha equals 0.05 on the two-tailed test for a degree of freedom of 18, and what do you get?
2.101.
2.101. All in favor? Now let's go back to our drawing. So our T critical was equal to what, 2.101? Good. Now our T test was equal to what?
1.85.
Okay, so did our test come out in the reject zone or fail to reject? Karen, did it come out in the reject zone or fail to reject? Paul, reject or fail to reject? Remember, this is the fail to reject zone.
Oh,
Yeah.
Yes.
failed.
No, this is the reject zone, you're
Yeah,
right.
it did.
Okay,
In the
this is the
reject
reject
zone,
zone, so we came out in fail to reject, Drew. So we are failing to reject the null hypothesis, agreed? In other words, if it is in this zone, then it's held to be a significant test. A significant test is one in which you reject the null hypothesis. It's insignificant if you don't reject it, your test has no bearing. It's inconclusive. Your test is significant if you reject.
So we're
We're failing to reject,
failed.
Right.
so this test is not significant.
0 to 1.85 is before.
That's right,
To
it is before.
I was going the other way.
That's right, I do that sometimes too. Yeah. Okay, so that was a moderate-sized problem. Some of these are not moderate-sized problems. So that was number 8, and our conclusion, is this correlation statistically significant? And your answer is, no, it's not statistically significant. You must still sit on the only information you have, that row of the population is 0. Your sample did not budge you off of that situation. Okay, does everyone want a 10-minute break? Or keep going? How many want to keep going? How many want a 10-minute break? So we need people to decide. Everyone make a mental decision. Okay, go ahead, cogitate, decide. One more time. How many people want to keep going? How many people want a 10-minute break? Go, 10 minutes. Bernie voted both sides. We'll come back at 5:59.
Like I said, I was out to irritate my husband.
Yeah. Something to eat.
Now, where are you gonna get
I
something to
understand
eat?
that wives
Snack.
intentionally irritate their husband because they want to see if he's still involved.
Yes. Actually, he can't take care of himself, so I really have no fears.
Gotcha. Yes, sir.
Are you gonna have any talks tonight?
If anybody volunteers and we have time.
Okay.
You ready?
You had asked me to be ready, so I got
I
ready.
do,
Because
but
I
from
might
the
not
rate
be
it's
here
going right now,
on Friday.
and especially since people are going to be wet noodles, they're already semi-wet noodles, my expectation is that we're not going to be able to pull it off, because we've still got a lot of stuff to cut through. And thanks for being ready, I appreciate that.
Well, I thought I was going, so I might not be here Friday, but I just think I might have to make it on Friday. I gotta take my
Well,
wife to Hatchinode.
no, because I can give you a private viewing, I don't need you to miss that. I can listen to you talk solo after class, if it comes to that. And we'll invite anybody that wants to
I would,
also view it.
I gotta take my wife to the hospital.
Yeah, no, we can take care of you. Nice colors,
Yeah.
nice colors, never mind the content. Looks good.
Yeah, so I wrote down. And rho will always equal 0 if not given any other information.
Yes. In fact, most statistical parameters, if you're not given any information, you assume 0. What do you like about Lane?
That, if when it gives you the exercises, if
Yes.
you look them up online on that website, you can click the question on the bottom, and it'll take you to the relevant section.
I like that a lot.
And you
Where,
can,
where on, what line are you going?
the online statistics book, where you've got the PDF
Oh,
file,
really?
if you click on the questions, if you don't know how, you don't remember reading it, you can click
That's
on the
awesome.
bottom, it says relevant section.
We're gonna
click
share
it,
that with the
And then you
class.
can read it, about what it's telling you about, and it gives you like one or two. You click the other section, and it'll tell you, so I was like, I don't remember what this is, so like, when I get home, I'll click it.
Okay, we're gonna definitely share that with the class.
It doesn't give you like problems either, it's just like word explaining.
Mm-hmm.
Oh. Where's the rest of mine? This is. This. Oh. Exercise is 512. Yeah.
Phone
512, yeah.
so lucky.
Yeah.
Oh, oh, no, this is
Yeah.
for,
Hmm. This is it.
oh, yeah, yeah.
512. I know, I'm confused too.
I misunderstood. Oh, yeah, yeah.
let's get down and dirty. Let's do some calculations. So I have my XY data set on the table. Now, just eyeballing it, are you going to predict this is going to be positively correlated, negatively correlated, or no correlation? Looks like positive, right? When x's go up, the y's go up. So we're going to have to verify that with equations. So the first thing that we have to have is the mean of x. Now, Lane calls this m sub x. So you have to total this column. What do you get when you total that column?
Did you,
20.
20.
Yeah, each.
So how many data items are there?
fine,
Well, m of x is 4, agreed? Now we need m of y. Let's total that column.
did you, so, where did you go for?
45, so m of y equals 9, agreed? Now what Lane uses is a capital X for a data point and a capital Y for a data point. Get this straight or you won't follow his writings. And then he uses a small x for a deviation and a small y for a deviation. So now let's populate the column of deviations. So the first one is 1 minus 4, minus 3. What's the next one?
Oh,
-3,
Minus 1.
-5,
And what's the next one?
-7. Oh,
There's a
minus
5 minus 4.
1.
1. A 5 minus 4 is a 1 again. A 6 minus 4 is a 2. Agreed? Now, if you add these up, you will notice they all come to what famous figure? 0. The sum of the deviations is always algebraically 0. So now tell me what is the sum of the what are the y deviations?
Sorry, Brian.
So Sean, what's the first y deviation?
Yeah, -5,
-5. Next.
-3,
Next.
1,
Next.
3. No.
That'd be the same. Oh wait, that's not a
That's
1, that's a 5 minus a 9.
Yeah, 12.
No, it's
Let's
a
redo
12
these.
minus 9.
Yeah.
No, 4, so it's, yeah, I'm in the wrong column. So it's a 10 minus a 9, which
Yeah,
is 1.
one.
12 minus a 9 is a 3, and a 4.
4.
So if you sum these, do you get indeed the famous 0?
No.
Yes.
Oh, okay.
Okay, good. They sum to 0, so that's just a check. Now, we're going to need x times y. Now, these are lowercase, so it means this column times that column. 15, 3, 1, 3, and 8. And now we're going to need to sum that column to 30. Okay? Now, we need x squared, this lowercase x squared. And we need to sum that column too. 16. Now we need the lowercase y squared, which are the y deviations. And we sum that column and we get 60. Okay. Now that we have our columns in effect, we need to go to the calculation of r. And our r calculation is the sum of xy divided by the square root of the sum of x squared, sum of y squared. So now we just have to put in the numbers. And what do we get? What's on top? What's the sum of xy?
30.
Take it off the table, it's a 30. Over the square root of the product of two numbers. What are those two numbers?
16 and 60.
That's right, 16 and 60. So do the arithmetic and tell me what is the correlation coefficient. Okay, by the way, this is in Lane on page 178.968.
This is what I'm trying.
Okay, this is in Lane on page 178. Same data table.
I have a question.
Yes, ma'am.
So this big formula for R, you shortened it into that little one?
I did. But you can use the big one if you want to.
Okay.
Because the big one does not require the calculation of the means. It just works with X and Y. So it might look big, but it might be faster. And if you want, you can use the big formula, just use X and Y, and you will get .968. Some say it's easier, some say it's not.
So that's the shorter version of the big long.
This is the shorter version, but it requires more table columns.
Right.
The big one just requires the first two columns. You don't have to generate these other columns. Well, you do have to generate X squared and Y squared. I apologize.
But the X squared and the Y squared are just from the original X and Y?
No, it's lowercase. Notice this is a big deal in Lane. This is a small x, right? So this is the square of the means.
Oh, that's fine.
Yes, let's make that one more time. Capital X and capital Y are data points. Small x and small y are deviations in Lane, not in Ilkowski. But in Lane they are.
So either way you make one.
Either way you do about the same amount of work, the big one or the small one. So now I want to calculate the line of regression. So I'm going to have to erase this, so I have some space to work while the table is still visible to you. The formula for the line of regression has a slope. B is equal to the summation of x, summation of y, over the summation of x squared. And remember, these are lowercase. Oh, wait a minute. Summation of x times y. Yeah, x times y. Summation of x times y. Okay, over the summation of x squared. Gives you the slope. So what do we get for the slope? Sorry? 1.8? So the slope is equal to 1.9, rounded off, agree? Now, what we have to find is the y-intercept, A. So we have to go to the equation that for any points that are on the regression line, y is equal to bx plus a. That means y is equal to 1.9x plus a. And do we not know that x bar comma y bar is on the line?
Yes.
So indeed, this point is on the line. And that point can be used now to find a. I'm calling them x bar and y bar now because I'm slipping into Ilkowski's notation. Do we not know that mx comma my is on the line? So the mean is always a point on the line. So we could have put in those values. 9 is equal to 1.9 times x, which is 4, plus a. That tells you that a is equal to what?
1.9
have the equation for the line of regression, y is equal to 1.9x plus 1.4. Only, we call points on the line of regression y prime. So we indicate that as a y prime. So now, I want you to do Lane chapter 4, number 6. Lane chapter 4, number 6. And each one, we'll do it on the whiteboard. Lane, am I doing the right chapter?
You mean 8?
Lane chapter 14, number 6. Did I say 6?
No,
You
I
said
said
4. Chapter.
Lane chapter 14, 4 plus 2, 6. Number 6 on page 512.
Okay.
So let's be sure we have it right. Sean, can you read the problem?
For the X, Y, data below computer.
Okay, we've got it. Now the data table is on the next page.
Last switch. It is all-
Okay, so let's eyeball it. Do people expect that it's gonna come out positive, negative, or 0? My God, they're all over the place, aren't they?
Yeah.
It's a net positive though, isn't it? Okay, so now we eyeballed it. Let's get the actual number. Anywhere on the board, the brave people will go directly to the board. The human people will do it on paper first.
Okay.
Lynn's brave. He's gonna go straight to the board. So I'll be back 10 minutes, eh? Keep your ear open for these guys, eh? So remember the equation for R, in case you forgot it, is that R is equal to what? R equals the sum of xy over the square root of the sum of x squared, sum of y squared. Or the long formula. Wow, awesome.
Maybe I made some mistake.
Hmm? Second, Ernie, let me show this to you, Cooney.
Maybe I made some typo.
So what problem number is this?
Oh, then what?
Can you write it down in that corner, Lane, in the lower right corner? Yeah, Lane, chapter 14, number 6, right?
Let me think like.
Well, sometimes I have.
Lane, chapter 14, number 6.
Yeah.
Okay, you guys want to put your esteemed results up on the whiteboards also?
Same. Oh, you have to make this one column. This one minus the mean. X minus this one. This one big X, this one small.
Okay. So, anybody else get results? Anybody get an R value?
I got one here.
0.85?
Live is very. I got 0.9. 0.912.
.916.
0.85.
Well, guys, put them up there. We're gonna have some confrontation. Come on, put yours up there. Never mind this one, put yours up there. Okay.
Some rounding though on mine.
So, yeah, put yours up there. We'll do some comparison. Whiteboard time.
0.85?
Sorry about that.
My fault.
So that 1.8.
What, 185?
She got .85, I got .916.
You got 0.85?
Yeah.
That's what I got.
Well, we're gonna have a winner and a loser.
I'm right for once.
Well, we'll see.
Try
Maybe
your
you're
4.8
got
times
company
5.
in the losing bracket.
Not 20.
Oh, we got some brakes on these wheels here.
Yeah, but we don't set them, set them, go ahead. Just remember to unset them.
Oh, yeah.
Times
Of course.
5.
Okay, so
24
I
not
guess we might as well raise this stuff here.
Yeah, it all gets erased, so put it on up there.
20.
Oh, is that your razor?
Sometimes maybe I
Oh,
need to,
okay.
so maybe you can find errors.
Put it back
I made a
there.
lot of.
So you got the same number I got here.
98.
Yeah.
I did 176. Yeah, just this one. But this one also,
You want the whole thing? This would be 0.
yeah. And
The
then
whole 9 yards.
3.2
Alrighty.
times
Get
5.
used to paying your dues, get used to writing big tables. That's what this
3.2
week is all about.
times 5 is 16 and 15.2.
It's okay.
I wish I had one, but I don't. But since we have some divergence of opinions, we're going to have to see exactly what numbers the divergence occurred on. It's easy enough to make a numerical step anywhere in this calculation. It'd be inhuman not to, actually. Main reason I don't attempt it myself.
I don't know if you got this.
I'm sorry.
Maybe I made some mistake. No, I think it's 0.1
.17, you put .8, I think it's just rounding.
Oh,
Yeah.
I think
Did
it's
you
just,
just go to tenths? You didn't keep 2 digits?
I said .17, you put .8.
That's not very close to .17. She said .18.
Oh, so I don't know.
I don't either. But you guys, if you reduce decimal places, then round, don't truncate. And you should keep, if you wanna do it right, you should keep 3 decimal
Oh,
places
so
during the
right out of
calculation,
now.
but 2 is enough for tonight.
do you have answers for this one? No?
So this is a good homework problem, too easy for a test problem, but good homework problem. People are definitely catching on. Three eighths are 24 and 6 is a 30. Carry 3, 10, 12, 15. No. I don't know if it sums to 0 or not. I was just talking to myself, I'm sorry. Nobody else will listen.
Because this 2.2 from the negative 3 is a minus 6.6 high. So you have to subtract that.
So 11 minus, minus 11 minus 14 plus 14, that adds to 0. 4, 3 eighths of 24. Oops, 3 eighths of 24. Uh-oh, your x's don't add to 0 then. These don't
Because
add
I
up to
truncate
0.
the decimals.
Okay.
I just did 7.8.
You just did 1/10, that's not good enough. You need 2 decimal points. Yeah, that's not good enough.
6.2 plus 2.2
Mhm.
plus 2.2 minus 2.8 minus 1.8 minus 2.8. It adds to 0.2.
Yeah,
0.2.
well, he gets 125, which is quite a bit different than 112.
Because of this negative
Uh,
6.6 high, when you multiply 2.2
There it
times
is. 36, 25, 25, 9, 81, 176, I got
The whole
150.
thing is.
Thirty-six plus 25 plus 25
There's one very tricky minus sign in
plus
there.
9
Yeah.
plus
The
81.
whole thing is.
Oh, there it is.
は22.8、20.0、10。あ、マイナス6.6、55.8。それで、
So that's,
収納
that's what it is, okay.
掃除は
So far, this has taken 9 minutes, which is a lot shorter than I expected. Paul, you're awesome. You didn't do the slope though, you didn't do the
Oh,
line.
I'm doing that right now.
Gotcha.
X の事情、これの X の事情。
Statistically close enough.
Small
X.
X.
All small X.
Yeah, my numbers are slightly,
That's okay, everybody's numbers are slightly, yeah.
yeah, but wait a minute, how did you, yours is completely different thing. How did you get that?
Is it?
Yeah, just a second here.
Oh. Yeah, I think mine's right.
Yes.
I'm scared. Hit the other two.
There we go.
So,
Same.
yeah. So after you get 0.85, that's it.
Yeah, then you have to find the regression line.
Oh, this one's still up. You have to find the whole regression line? The slope of the regression line. So we're looking, you want us to put down the whole regression line or just the slope?
Well, the whole line,
Okay.
just for practice, get the 8.2.
You just you know this 2 points, right? And you know that these are in your line. So you use this one to find A. So Y is
Yeah,
this
but
one.
now. But see, I didn't get, how did you get 0.85 for B2?
0.85 is your R, right?
Yeah.
So you plug that one in, and X is 7.8,
Hmm?
and this will give you A.
The,
You don't have to use that formula.
This is small.
So you don't have to find B?
That's your P. Bx, that R is, that's your P. That's your
That's a
slope.
big X. That's a big X. That's right. Well, Nubs just pointed out is that this is a big X in this equation. These are real data values in the line equation. That's later, not now.
Well,
Noakowski is much, much easier than Lane. We're just doing Lane tonight because after you do Lane, you're going to find Noakowski as a walk in the park. Oh, you're working ahead to what? Significant? You can't do significant till I teach you some stuff. But you don't really know how to do it, do you?
Significant? It says the 95 confidence interval.
Well, that's not assigned, I only did A and B.
X, Y.
C is not assigned, C is not assigned, check your assignments.
You gotta do that.
Well, you can't finish B until I do some more teaching.
So I got
Seven.
1 point.
So I was like,
Yeah,
what
I made a mistake too.
Okay, so congratulations, everybody, give yourself a pat on the leg,
No, he said A and B.
just A and B, not C. C we won't do in this course, you can do that in the next course.
So,
Sure,
Well,
there's always a next course.
no.
I teach
Somebody's
physics.
game because I got messed up by her.
You gonna teach physics here?
I'll teach physics as soon as we can fill a class.
so X, Y,
I'm trying to do it this summer.
X, Y, 98.84. Hi, so mistake. B,
I got a mistake.
yeah, this one, 112
Oh, it depends when the summer.
divided by
Does it end for
98.84.
July?
So,
July 21 or something like
1.163.
that.
So now, y prime is equal to
She missed me up.
this one,
Lynn
1.13
messed you up?
x
Yeah,
plus a.
I was about to do the formula. She
So,
told me I was wrong.
Which one?
Huh?
No, I made a mistake.
Yeah.
So,
Just
so
second.
y is,
She was saying, she told me that
12
R.
is equal to
Lynn, one more time, I made a,
3
repeat.
times
I ain't got
Lynn, one more time,
plus
I ain't got
a.
nothing to do with that.
I made a,
I got 3.8.
I
One
made
point
that.
one three,
I ain't got nothing to do with that. I ain't getting.
So,
So which formula was she
12.
using?
Yeah.
Well, she forgot it.
8.8,
I was about to do it.
Oh, she
So
just did an R,
She was
didn't she?
telling
Yes,
me
we got
that.
two.
Oh.
Wow,
Oh, I
I
didn't even catch it.
Yeah.
So
Yeah, I
12
didn't even
minus
catch it, my bad too.
8.8.
Trying to keep it down. That's what it is.
No,
So,
Trying to keep me down.
3.1
I'm trying.
good, well done.
Hi, so
What's the 1.6? Oh,
y
So
prime
Yeah.
B,
equals
B is not the same as
Said
R.
what?
So like
1,
wash
3
it on, you get it.
I know,
plus
last week, right?
Look at you.
3.186.
Last week, by George, she's got it.
yeah, I got that. Okay, I did that right. So we're doing A, B, and C, sir?
Right,
So, we came together as a
112
class,
covers
some
the
did
sum
some,
of
some
x
did the
squared.
other, and I did only some too.
So 1.13, huh?
Yes.
Yeah, 1.13. Yeah, that's
So,
correct, right?
yeah, so this one is x bar.
I think we're gonna.
So we're doing A and B.
Numbers.
Yeah, that's all good. I just wanted to.
No C?
No, you don't have to do this.
Got part of it right enough there, might as well finish it.
When I read it, I was like, oh.
Okay, so I need to bring everybody's attention
I
that,
don't know. what we're gonna do.
I myself did not catch the fact that R and B are not the same number. Once you have R, there's still any formula for B that you have to put down and find B. So everyone do that, now, we all got that together. Okay, I'm gonna finish out part B. Part C is not assigned, that's for a later course. But I'm gonna finish out part B on this, and that is the slope significant? Is the slope significant? Meaning, can you transfer it back to the population? That's what, all right, you said you were gonna turn them off. On camera, you said you were gonna turn them off.
We both forgot.
I knew you were gonna forget. There's still one more. Got it. Okay. Now, I've got to remind you of these pretty colored little lines again. Now they're a little bit more familiar to you. So this is a Y value, and this is the regression line, and this is Y prime. And if this is the average line, then this is Y bar. Okay? Now, this black distance is known as Y minus Y bar, and it's just a deviation, agreed? And the sum of Y minus Y bar squared, because the sum of the lines adds up, and this the green line is the explained part. The explained part is y prime minus y bar. So it's a sum of y prime minus y bar squared plus the sum of the residuals, which is unexplained. So this is the residual, which is y minus y prime equals residual. So this is the sum of y minus y prime. Okay, so that looks good. So now let's give them some names. This is called the sum squared of y. The sum squared of y. Because it's the sum squared of y measured off of the average line. And this is called the sum squared of y prime. And this is called the sum squared of the errors. The sum squared of the errors, because the residuals are the errors, agreed? So these are the terminologies. So with this in mind, we can now do Lane chapter 14, problem 5A. Lane chapter, page 512. Lane chapter 14, problem 5A. In a regression analysis, sum of the squares for the predicted scores is 100. So which one of these three are the predicted scores?